Hello everyone. In this video, we'll talk about bivariate frequency tables and the Pareto chart. So, what are the bivariate frequency tables? So far, we have only covered tables with only one variable, with a single variable. But it is possible to have a table that has two variables at the same time. So, using a familiar example like this one, so remember that in this example, we had days, machines, number of failures, and the operation number. So we can summarize the data, but now we're going to analyze two different variables. Machine, so we have the machines in our rows, machine A, B, C, D, E, F, and in the columns, we don't have only one column here. Now there are three columns. So the variable that we have in the column is the operation number. That will be the fourth row. This one, this one, this one. That's the number of the operation. There are three operations. So what we're checking these tables, it's which machine was used, like how many times each machine was used to perform one of the three operations. So we have three columns with frequencies here, first, second, and third. So this is what we call a bivariate frequency table. We call it bivariate because it has two variables. Now, since we have a bivariate frequency table, we can create bivariate bar plot. So in the bivariate bar plot, we can, like toy around with these plots. For example, if we have the machines in the x-axis, then the operation is going to be represented by the colors. So for example, machine A was used only in operation number 1. We don't have machine A in operations 2 and 3. Now the machine B, for example, on the other hand, it was used in the three operations. So we have the three colors, the three bars. With machine C, it was used in two operations, in operation 1 and 2. And we can keep going with the analysis. Now, it is possible to change the colors and the x-axis. So instead of machine in the x-axis, we might have the operations here. So here, instead of machines, this will be the operation. The operation. And the colors, they represent the machines. So now in the first operation, we have all the colors, meaning that we are using all the machines. And finally, if we check the third operation, there are only two machines that were used to perform that operation. So that's a bivariate bar plot where we are visualizing the frequencies of two different variables at the same time. And we can answer some of the questions. So here we're being asked first one. So what's the percentage of days machine A of what is the percentage of days machine A usage of the machine A usage? So if we go to a table, see how many days we're using machine A. So if we add this row, let me unclor this, erasing a little bit. All right. So the minimum information here is the row, like in how many days the machine A was used, so in total 10. So then what is the percentage? Will be 10 divided by the total number of days. That will give us the percentage of the usage of that machine. So it's 10 divided by 56. The second question is what's the percentage of days operation 1 was performed. We go to the table and we check operation 1. So in the case of operation 1, that's the first column. So from this column, we know that the operation 1 was performed in 35 days, right? Therefore, the percentage is going to be 35 divided by 56, which is the total number of days. It's 35 divided by 56. And the last question is, what's the percentage of days where machine B and operation 1 were performed? So here it's important is and. The and represents the two occurrences like at the same time. The two things happen at the same time. So machine B and operation 1. So that's the intersection of that event. B and 1. B and 1. Then if we go to B and 1, we find the intersection. So that intersection is given here. B and 1. Therefore, 11. We have 11 days in which machine B was used to perform the operation 1. So the percentage is going to be 11 divided by 56. So this is an example of how you can use these type of bivariate tables or bivariate plots. All right. So the last plot that we're going to cover in this video is the Pareto chart, which it's a mix of two different plots. And let's see what is the purpose of the Pareto chart. So there is something that is called the Pareto law. The Pareto law was defined by Wilfred Pareto, and it says that in general, 20% of the problem or causes create 80% of the effects. That's like, for example, if you start thinking of what are like your problems, you make a list of the problems that you have right now, but I'm pretty sure that none of the problems that you might have, they have the same importance. Most likely, only few of those problems are creating most of your stress, right? So that's the Pareto idea. So only like the few causes or the 20% of the causes will create 80% of the headaches or the effects, right? So that's the Pareto law. Then, in order to find what are those few causes that are creating most of the problems, we create this tool to be able to identify what are those causes. So let's check this example. It says that a local transportation agency has identified the causes of traffic accidents in a busy intersection. So let's create a Pareto chart, and we are given the different causes. So B stands for high speed, S lack of traffic signals, Z driving under the influence, that means alcohol or drugs, R mechanical issues of the car, of the vehicle, A animals on the road, and lack of sleep. Someone's tired, maybe that person is taking, like a summer course, 5 hours every day, during 5 days. That's a lot. And O means other cause. So we know the frequency of each of those causes. So the first thing that is required in the Pareto chart is that we need to arrange from the highest to the lowest frequency. So we need to rearrange the table from the highest to the lowest frequency. So this is what we do here. So using the absolute frequency, our table goes from frequency 32 up to frequency equal to 4. So remember, Z means driving under the influence. So that's the main cause of accidents in that intersection. Others, it's the cause that has the less influence in the accidents. So once we have our table, and the table was arranged from the highest to the lowest value, next step is to compute the cumulative frequency. So you find the cumulative frequency and using a percentage format. And with that information, you create the Pareto chart. So the Pareto chart, it's a combination or a mix of the bar chart and the ogive plot. So it is increasing, while the bar chart is always decreasing, because remember we go from the highest frequency to the lowest, so the bar chart will decrease. I'm sorry, and the ogive plot is always increasing. Now, what is the purpose of this Pareto analysis? The idea is that you can identify what are those few causes that are creating most of the problems. So here we know that these four causes, Z, N, D, and S, are creating 80% of the accidents, right? So you're identifying what are those few causes that are creating most of the problems. So that's the idea of the Pareto chart, to be able to identify what are those few causes. In general, you will get the 20-80. I mean, the 20 causes that create 80% of the problems, but that's not always the case. For example, in this problem, we're not getting exactly the 20-80. It's a little bit far from that. But that's just a reference. That's just a reference. So it gives you an idea on that you should focus on those few causes that are creating most of the problems. So it's not like an exact rule that always will be satisfied. It's a guideline in your analysis. All right. So I'm gonna stop here. And in the next video, we will start talking about numerical analysis in descriptive statistics. So it's more about metrics. So I'll see you around in the next video.